Let's consider the rates of chemical reactions, and this is called chemical kinetics. Let's consider a simple reaction, say a reactant A producing a product P through some sort of chemical process. We can define the rate of the reaction as the disappearance of A with respect to time, or the appearance of product with respect to time. So this just means that the rate is equal to the change in the, say, concentration of reactant A divided by some time interval, and that's the rate. So it'll have units of concentration, say molarity, divided by time. Now say we have a reaction, say 2 A's reacting to give a product. Now in this case we have product appearing, but we have reactant disappearing twice as fast because it takes 2 A molecules to produce 1 P molecule. So A is disappearing twice as fast as P appears. So the rates will be different. The rate of A disappearing is twice that of P appearing. But it's convenient to express the rate of chemical reactions regardless of the reactant or product and their stoichiometry. So we want to define one rate of reaction. So we can do this by saying that the rate is equal to 1/2 of the disappearance of A divided by a time interval, and that's equal to the appearance of product over that same time interval. We use this factor 1/2, and that's the stoichiometric factor in the balanced equation, and that just gives us a rate independent of whether we're relating it to a reactant or a product. Now another thing we have to consider is that since A is disappearing, delta concentration of A is going to be negative. Therefore, the rate is going to be negative with respect to A, but since product is appearing, delta P will be positive, so the rate will be positive with respect to P. We want to have the rate be the same sign, and so we'll use a negative sign to make the rate positive if we're talking about a disappearance of a reactant, and we'll use a plus sign to show that the rate is positive when we're talking about the production of a product. Therefore, if we have a general reaction where little a, b, c, and d are the stoichiometric coefficients for the balanced equation, and the capital A, B, C, and D are reactants and products, the rate will be equal to -1 over A, little a, times the change in concentration of reactant A divided by a time interval. That's going to be equal to -1 over little b times the change in the concentration of reactant D over that time interval, which will be equal to 1 over C, and this is positive, so I won't write the positive, and times the reaction or the concentration change of C over that time interval. That's equal to 1 over little d. I left off a delta here. Times delta change in the concentration of D over that time interval. So remember to use the stoichiometric coefficients, and remember to use the proper sign in expressing the rate.